In this video, we're going to be discussing how to solve this question in Algebra 1 about quadratic equations and circle graphs. The problem statement says, find all x-intercepts of the graph of x squared minus 2x plus y squared plus 6y minus 15 equals 0. So we're going to need to use a technique in this problem to find the x-intercept that involves setting the y-coordinate equal to 0, because every x-intercept coordinate is going to have a y-coordinate equal to 0 and an x-coordinate of some integer value. But before we do this, we need to get this crazy complex form equation into something familiar we know how to solve. Now, there's a standard form that's going to be very important. That's going to be our goal to try to get this equation into. It's the standard form for the quadratic equation graph of a circle, and it appears as x minus h squared plus x minus k squared equals r, where r is the radius of the circle, and h comma k is the center. So this is the target form. This is what we're trying to turn this original crazy equation into. It's that second form there. So to do this, we're going to need to use the completing the square technique, specifically on the x squared minus 2x and the 6y, the y squared minus 6y. So we need to use the completing the square technique on these two portions here to finish up that perfect square portion, so we can get it into the familiar x minus h squared and x minus k squared form. So to do this, we're going to need to use the useful formula b over 2 squared, or negative b over 2 squared. I'll write this over here, to find what number we need to add to these equations. So it's going to be negative 2 over 1 in this case, or negative 2 or negative 1 squared, which is going to be 1. So all we have to do here is add 1, which means, and the factored form of this equation is x minus 1 squared. And you can test this by expanding the product. You'll get this original equation. Now we do the same thing for y squared plus 6y. Negative 6y over 2 is negative 3, and then you square that and get 9, so plus 9. So that factored form is y plus 3 squared. And you can expand that, and it will be this original equation as well. So we have these two completed squares now, these binomials, and you can see they're in the same form as these x minus h and x minus k squared pairs. So we've got the correct form now. All we have to do is combine these two binomials, so x minus 1 squared plus y plus 3 squared equals r. We don't really care about the r. The value for r in this case should be 25, because we add 15 to both sides. We have 15 here, then we added 10 to both sides by completing the square. So 15 plus 10 is 25. So r is 25, but we don't really care about that because they don't want to know the radius. They only want to know the x-intercepts. So from here, the next step is to set y equal to 0 in this equation here, and then find out the values of x that satisfy the equation. In fact, it will be helpful to know that the radius is 25, because that gives us an extra quantity we can use to find out the value of x. So let's go ahead and set y equal to 0. We still got our x minus 1 squared here, but then since y is 0, we wind up with 3 squared. That's all equal to 25. So then, 3 squared is 9, so plus 9 equals 25. From here, all we have to do is isolate the x minus 1 squared, so x minus 1 squared equals 16. From here, it's pretty easy to find x, because we know that the value inside this parentheses right here must be 4, because 4 squared is 16, or negative 4. There are two possible values here. So we've got x equals 5, that's one possible value, that's the positive one, or x equals negative 3, because negative 3 minus 1 is negative 4, and negative 4 squared in this case is 16. So those are our two values for the x-coordinate. They want to know the entire x-intercept, so our two final answers are 5, 0, and negative 3, 0. So that's how you would solve that problem. Pretty simple. All you have to do is first complete the square. First, what you have to do is complete the square to get the original equation into a correct and familiar form. The x minus h squared and x minus k squared equals r form. Just by completing the square on the original equation, then from there, all you have to do is set the y-coordinate equal to 0 in that new form equation, then isolate the x minus 1 squared, and you've got your answers for the values of x. That's how you'd solve that problem on quadratic equations and circle graphs in Algebra 1.